Welcome to this explainer. As archaeological analysts, we're diving into a genuinely staggering breakthrough from the Jordan Valley today. We're going to rigorously examine the technological and cognitive capacities of early hominins, specifically through the lens of geochemical analysis. The level of technical forensic work required to pull these truths from a landscape that has literally been buried by time is just mind-blowing. Okay, let's decode the deep past.
To set the baseline for our intellectual review, we have to formally credit our foundational text. This brilliant research was published in the highly respected journal Scientific Reports in May of 2026. Authored by Tsai Golan, Yoav Ben-Dor, and Nama Gorin-Inbar, this paper gives us an absolutely unparalleled look into the Acheulian site of Gesher Benot Ya'aqov, which we'll just refer to as GBI. Their integration of geological and archaeological evidence is the baseline for today's analysis.
Here is our strict 5-part structural agenda for breaking this down. First, the GBY Breakthrough Study. Second, the Dead Sea Transform Challenge. Third, the Subsurface Geochemical Methodology. Fourth, the Cleaver Sourcing Anomaly. And finally, Hominin Planning Depth. Let's kick things off with Section 1, the GBY Breakthrough Study, contextualizing the Acheulian site. So, GBY is this crucial early Middle Pleistocene site, and it's defined heavily by the complex production of bifaces. Those are stones systematically flaked on both sides to create a sharp edge. The critical raw material in question here? Basalt. The Acheulian culture relied heavily on this incredibly tough volcanic rock to manufacture their most essential tools. We're talking giant cores, handaxes, and specifically cleavers. And you know, working with basalt requires immense skill and force. It is not like knapping flint at all. It demands a distinct, highly complex manufacturing process. These hominins weren't just making do with whatever was lying around, they were executing highly skilled, intentional crafting. Moving right along to Section 2, the Dead Sea Transformation Challenge and the Tectonic Burial of Evidence.
To really understand hominin behavior, we have to know where they actually got their basalt. But the site sits squarely within the northern segment of the Dead Sea Transform. This is a highly active tectonic fault zone. The Earth here is constantly moving, shifting, and tearing apart. Over hundreds of thousands of years, this severe geological instability has caused the ancient basalt flows to be drastically altered. Earthquakes, subsidences, and erosion have literally buried the original landscape walked by these early hominins deep underground.
This leaves us looking at two starkly different realities. First, we have the surface basalt. It's visible today, but heavily altered by erosion and time. In sharp contrast, we have the subsurface basalt. This is the hidden landscape, buried deep by tectonic shifts and completely inaccessible without modern drill cores. So this presents a massive forensic challenge. How on earth do you link an ancient stone tool to a basalt flow that no longer exists on the surface? Well, you have to look underground.
Which brings us to Section 3, Subsurface Geochemical Methodology, the forensic tracing of lithic artifacts. To solve this buried landscape problem, Golan, Ben-Dor, and Gorin-Inbar utilized a rigorously analytical approach. Let's walk through the 4 precise steps of this geochemical profiling. Step 1. Sample the artifacts themselves alongside the available regional geology. Step 2, and this is where the heavy lifting comes in, extract subsurface drill cores to physically pull up the ancient buried basalt flows. Step 3. Conduct highly advanced elemental mapping on both the tools and the drill cores. And finally, Step 4. Apply multivariate statistical matching. This essentially means using complex data algorithms to see if the chemical signature of the tools precisely match the chemical signature of that hidden geological landscape. And this brilliantly illustrates the depth of their analysis. They didn't just look at basic rock composition. They analyzed major elements, trace elements, and rare earth elements. Think of these as microscopic elemental markers, because every single volcanic eruption has a slightly different chemical makeup. Based on its mantle source and cooling process, these rare earth elements act as a unique, permanent fingerprint. By mapping these markers, the analysts were able to establish a definitive compositional range for the available basalts around GBY.
Now for Section 4, the Cleaver Sourcing Anomaly, a divergent procurement strategy.
When the research team mapped the archaeological specimens onto this newly uncovered geochemical landscape, the data revealed a really striking divergence. The vast majority of the artifacts were, as you'd expect, produced from immediate local basalt flows. That makes logical sense from an energy expenditure standpoint. But look at the minority subset.
A specific group of tools mapped onto distant, unexposed basalt flows, flows that are currently buried completely beneath the surface. This subset absolutely breaks the established pattern of local convenience.
The crucial point here is understanding which tools fell into that anomaly. Common tools, like handaxes and giant cores, were produced from the local basalt. But the cleavers are a completely different story. Acheulian hominins specifically and intentionally sought out distinct, distant basalt sources almost exclusively for crafting cleavers. Think about that for a second. They walked right past perfectly usable local basalt, traveling farther afield to locate a highly specific type of rock for this one particular tool. This is a targeted, highly selective material procurement strategy.
Finally, Section 5, Hominin Planning Depth and the Cognitive Implications in the Pleistocene.
Transitioning from the hard geochemical data to the profound cognitive implications, we really have to contextualize the temporal scale to appreciate the magnitude of this breakthrough. We are talking about structured, cognitive behavior that occurred 780,000 years ago. It literally took modern science, utilizing subsurface drill cores and rare earth elemental mapping in the present day, just to verify a strategic decision made by hominins nearly 1 million years in the past. That is absolutely wild.
Ultimately, these findings highlight a remarkably selective, structured approach to basalt exploitation. The hominins at GBY possessed an intimate, nuanced understanding of their dynamically changing landscape. They knew that not all basalt is created equal. They recognized that the specific mechanical properties required to nap a functional cleaver demanded a very specific type of basalt. Most importantly, they possessed the foresight, the spatial memory, and the planning depth to travel to those distant flows to get it. This completely dismantles any old ideas of primitive opportunism and replaces it with undeniable evidence of complex, premeditated technological behavior.
As we wrap up this explainer, we're left to ponder the vastness of what we still don't know. If early hominins exhibited such advanced planning depth and hyperspecific material selectivity 780,000 years ago, strategies so complex they require multivariate statistics and drill cores to uncover today, what other immense cognitive milestones remain undiscovered, waiting quietly beneath the shifting tectonic plates of the Earth? Thanks for joining us for this explainer. Keep questioning the layers beneath the surface.